All right, so we're here again for a physics problem, which is a mechanics problem. You can also say this in your uh, physics also. Physics and mechanics is the same, it's just mechanics is more specific. All right, so two particles A and B of masses m and 3 kg are connected by a light inextensible string. Particle B is on a fixed plane, which is at an angle of arc sine 0.6 to the horizontal. The string passes over a fixed smooth pulley and particle A hangs vertically above and it is 0.75 above the ground. The system is released from rest. In the subsequent motion of P, motion B moves up. So this direction is up. This is down. This is down like this, okay? And they also told us as particle B moves up the plane or moves up the plane, there's a constant resistance as particle B. Okay, the system is moving forward. Subsequent motion, B moves up. Okay. Okay, B moves up, not down. Okay, so I think I'm ready. So the string passes over, okay. The string passes over a fixed pulley at the top. Okay, particle A hangs above. Okay, B moves up. So this comes down. B moves off the plane. Okay, and the resistance of its motion is that the speed of A before it hits the ground is this. So we are told specifically to use the work energy principle. So you cannot use any other method to solve this. If you use, you get no mark. So use work energy method. And the principle states that the work done by a driving force minus the work lost to resistance and the gain in potential energy equals the total gain in kinetic energy. Yeah, that looks like bullshit, right? It looks like something else. Okay, so I would just say we can also look at it like this: internal energy is equals to final energy plus work done against resistance. So we can look at it like that. So internal energy is equals to final energy plus work done against resistance for this question. Now let's break it uh, one by one. Let's find the change in kinetic energy first. So the change in kinetic energy will be 1 over 2 mv squared at A. Okay, 1 over 2 mv squared at A plus 1 over 2 nv squared at B. So because the particle from A, it moves. From B, it moves. So change doesn't mean we're going to subtract them. No, it doesn't. We're not going to subtract them. So another way you can look at this is the potential energy loss at A, because A is moving down. So A loses potential energy is equal to potential energy gain at B. B moves up plus kinetic energy gain by both. So both of them gain kinetic energy. B moves up, gains energy. A moves down, it gains energy. Then plus work done against friction. So there are different ways for you to visualize the problem. So this gives me, so from there I'll have 1 over 2 m is 3 plus m times the speed will be the same, right? Because particle is moving at equal speed. So this is A, this is B. So the speed this used to come down, the same speed this used to go up. So this is times 2 squared. right? So when we do that, that gives me so 2, we cancel 2 here. That gives me 2m plus 6, or 6m plus 2, because I will just simplify this. We cancel, so 2m plus 6. So this is the kinetic energy, or change in kinetic energy. Okay, so at A, what happens at A? So at A, we have particle is losing kinetic energy. So, and we know potential energy. Potential energy is mgh, right? But it's been lost, so I will just put minus there. So there's loss in kinetic energy. So minus. So this is minus. Now the mass is m times g of obviously is 10 times. Now what is the height? They told us 0.75. So this gives me minus 7.5 m. See, this is at A. Now, what do we need to do here? So at B, what happens? So let's think what happens at B. So B goes up. So B goes up. So we need to find the potential energy at B. So potential energy at B is also mgh. It's not minus because it ascends, so it's going up. A descends, so that's why we put minus. So direction vectors, right? So because of the direction, we do that. So what do we do here? So we need to find the height in which it moves. So this will be so mgh. So we need to find the vertical height this moves. All right, so the plan is, how do we find the height in this question? How do we find the height? So you know that when this goes down, this goes up, right? So let's form a triangle here. This is also theta. So remember that theta is a sine inverse of 0.6. So sine theta is 0.6. So don't allow that to trick you, okay? So they're just trying to make it complex. So from here, so sine is, so I'm finding this vertical height because I need potential energy, which I need vertical height. So this is sine theta is opposite this, so this also moves 0.75. So from there I will do sine theta is h over 0.75. So my h will be 0.75 times 0.6. So that is my height. So I hope that makes, so that is the height the particle goes. So from there, I'll just substitute my values. So my mass is 3 times 10 times the height we already found. So 0.75 times 0.6. So I'll just press my calculator here. So 3 times 10 times 0.75, I get 13.5. So this is the potential energy when particle B goes up. So I have gotten some things. Now it is how we can put it together. But there's one more thing we need to do. They told me there's a resistance. So work done against resistance. Work is obviously force times distance, right? So they told me the force is 10 over 3 times What is the distance move? Can you tell me the distance move? The distance move is 0.75. So I'll just, so 10 over 3 times 0.75, that gives me 2.5. So remember, all whatever I'm finding, they are all in joules. So now let's apply the work energy principle. So we said internal energy. So internal energy is 0 at the beginning. Is equals to so I'm using that formula. I will just rewrite it somehow so that it makes sense. So 0 is equal to change in kinetic energy plus change in potential energy plus work done against resistance. So that's the same thing as the formula. So final kinetic energy, final energy. So energy is potential energy plus kinetic energy, then work done against resistance. So 0 is equals to for kinetic energy, I had 2m plus 6. For potential energy, I had this, so 13.5 minus 7.5 m, then plus work done against resistance 2.5. So we just do some math here. So this will give me 0. Okay, we move. Should I move? Okay, that will give me 2 minus 7.5. That gives me minus 5.5. Then we have 6 plus 13.5 plus 2.5, that is 60 as 22. This is m here. So m, move it to the other side, 22 over 5.5. That gives me 4. So my m is 4. So that is my answer. That is my answer. So I hope it makes sense. So you cannot deviate from whatever you were told. You were told use work energy principle, so you have to use that. If you do resolution of forces, that you will not get any answer. All right, so learn your principle. No, so as time goes on, I will do some more questions. All right, guys, take care of yourself and bye. Danke.